This is Looking Forward for Astronomy 100 for Monday, the 2nd of November, 2015. As you get ready for class on Monday, I'd like you to read Unit 61 and then review Units 22.4 and 30.1.1 of your book. And then what I'd like you to do is think about waves. Here's a wave going up and down, and remember that this distance from peak to peak is what we call the wavelength. We can give it the symbol W for wavelength, or L for length, or the Greek version of L lambda for length. Here's another wave, up and down and up and down. And clearly, as you can tell, this wave has a much shorter wavelength, W or L or lambda. It has a much shorter wavelength than this one does. Now imagine that what I did is I tried to send this wave through some sort of hole. And let's say I made the hole way bigger than this wave. Would the wave know that the edges of the hole were there? And if it didn't know the edges of the hole were there, what would happen to it? Would it go straight through, or would it bounce off the edges? Likewise, this wave, whose wavelength is about the same size as the hole, therefore, would it know the edges of the hole are there? And if it knew the edges of the hole are there, would it go straight through, or would it bounce off the edges and spread out? This process of spreading out is what we call diffraction. And so what I'm really asking you is, would a small wave tend to diffract around a big hole, or would you require a big wave, or a wave about the same size of a hole, to see diffraction? That's our first question. Our second question has to do with something called the principle of complementarity. Don't Google it, but here's the idea. Imagine that I had a hole here, and I sent light through, and light diffracted. It bent as it went through. Imagine that I had a small thing that blocked something, like this. And then imagine I had a huge hole like this. Now you could say that this huge hole would be equal to this screen plus the small hole plus this small blocking thing. Notice if I put that small blocking thing together with this, I would get a flat blank screen actually. How does the pattern of light going through a huge hole, therefore, compare to the pattern of light you get from a small hole and the pattern of light you get from a small blocking thing? Do you have some complementarity that occurs? And what does that mean about this concept of diffraction instead of through a hole, about diffraction around an object? We'll talk about that and more when we get together on Monday. See you then.